All right, so we saw how to find this antiderivative using the integration by parts formula. Now let me show you how to do it with the table method. Now the important piece is that the table method works only when you set u equal to the polynomial piece. So if a antiderivative doesn't have a polynomial piece, then you can't use the table method. Right, but all the ones, as far as I looked at your homework, and every single one of those in the WebAssign part, at least, is a candidate for the table method, I believe. All right, so the way we do this now is we have, so first let me write x squared e to the x dx here. And we still need to figure out our u and our dv. So u is x squared, dv is e to the x dx. And now let's make the table. So we've got u, and I guess maybe I'll put it over here. U and dv. All right, for u, we put in x squared. And now what we do in this column is we take multiple derivatives until we get to 0. So the derivative of x squared is 2x. The derivative of 2 is 2. The derivative of 2 is 0. And that's when we stop. And now dv, we put in our dv, e to the x dx. And now we take antiderivatives. So over here, this is derivatives. Over here, this is antiderivatives. All right, antiderivative e to the x is e to the x. And we just keep doing this until we get down to the same level as the 0. The 0 in the first column. Now we add in signs. Always start with plus at the top, left column. Plus, minus, plus, minus. And now we do this somewhat odd thing where we draw these arrows. So draw these arrows like that. And now our answer is, is going to be the first piece of our answer is going to be this, which is x squared e to the x. The second piece is going to be this part right here, minus 2x e to the x. And our third part is going to be this part right here. And you can check that that's exactly the same as the one, as part is the previous video where I found this using the traditional method.